Navigating a HM3000 handheld unit is relatively simple. The first step, of course, is to use the left-hand button, which is your power button, to turn the instrument on, which will bring you to a loading screen, followed shortly by the main menu. So we've already covered the use of our power button. In the center there is a central trackpad. Pressing down will simply allow you to scroll down. Pressing the trackpad up will allow you to go up. You can also go side to side, although on the main menu this doesn't really do anything. This is for use when setting deposition times or when setting the concentration of your standard addition. You can also press the trackpad central button down instead of as a switch, more like a button, and that is your select button. So if we were to press select again, it opens the cadmium lead menu. There's also this right hand button, which is your cancel button, which will take you back to the previous menu or cancel a process that is ongoing. We have on the main menu your test methods, which cover your conditioning steps and each parameter that the HM3000 is capable of. We have your data log, which allows you to view your previous results, and the system menu, which will allow you to set the backlight, date and time, language, your charging, your auto switch off, and a number of other system functions. In this video we will be covering the use of the TRACE2O pipette. Your pipette will arrive as shown. To begin the use of your pipette, it is first necessary to take a TRACE2O pipette tip and simply press it very firmly onto the end of your pipette. Once you have done this, your pipette is ready for use. You can change the volume with which you are aspirating and dispensing by turning the plunger at the rear of your pipette. Once you have your pipette tip firmly attached, it is best to take your pipette and familiarize yourself with the two-stop mechanism of your pipette. The two-stop mechanism is there to ensure the accuracy of the volume of liquid aspirated and dispensed from your pipette. For use, you can familiarize yourself by simply pressing down the plunger. What you will see is that the first step is very easy and has very little resistance. When you are aspirating your liquid, you press down to the first step, place your pipette tip within your liquid, and then simply release the plunger. As you will see, with aspirated liquid. The next part that you should note is that there is a second stop. The first stop was simply a barrier of resistance. If you only press down to your first stop, what you will have is a small amount of liquid still pressed within your pipette tip. To show you how to use the second stop, once again draw up the liquid you need using your first stop, and then you go down to dispense your liquid, go down to your first stop, and then press further until the plunger is fully depressed. This sends out a small cushion of air from the pipette, which empties the rest of the pipette tip and ensures the accuracy of your liquid dispenser. For the polishing and preparation of your Metalyser electrodes, you'll require your working electrode, your polishing pad, the glass plate, the plastic holder for the glass plate, your polishing slurry, and your electrode rinse solution. Plating is one of the more important steps required for setting up your Metalyser. A degraded plate, or a plate that is uneven, or in the case of gold plate, co-deposited with mercury, will cause severe problems with your accuracy, repeatability, and reliability of your measurements. The process of polishing is as follows. Take your pack of polishing pads and remove from the film packet. Turn over, and each polishing pad has an adhesive back which can be exposed by peeling away the paper film on the back of the polishing pad. Once this is exposed, take your polishing pad and align the polishing pad with the edges of the glass plate and attach, and then firmly press down so as to remove any air bubbles underneath. Once you have that done, you simply take your polishing pad on its glass plate and insert into its plastic holder. Once you have your polishing pad within its plastic holder, take your polishing slurry and empty a few drops onto the surface of the polishing pad. Take your working electrode. For parameters that require a gold conditioning solution, this will be a WE2 electrode, and for those that require a mercury plate solution, it will be a WE1 electrode. In this particular case, we have a WE2 electrode, though for polishing the process for both is the same. Take your working electrode and press the tip of the electrode firmly to the surface of your polishing pad, and then begin to move in a figure of 8 formation for 30 seconds. What this does is it removes all of the surface defects of the glassy carbon and also activates the glassy carbon beneath, making it ready for an electrochemical process such as your gold or mercury plating. Once this is done, you will have some alumina slurry from your polishing slurry left on the surface of the electrode, which is why I simply take any waste receptacle and your electrode rinse solution and gently rinse the electrode. You will now have a completely clean and polished electrode surface. If there are any scratches or any remaining residues or dirt, simply continue polishing until there are none left. This is an introduction to the HM3000 sonde and electrodes, and specifically the setup of both. Taking the sonde, what you can see are 5 different sockets for various electrodes. As you can see, each is labelled. We have an R for your reference electrode, C for your counter electrode, WE1 for your working electrode, WE2 for a working electrode and WE3 for a working electrode. The reasoning behind having 3 working electrode slots is that there are 3 different types of working electrode. With your HM3000, the ones that you will be supplied with is a WE1 glassy carbon electrode, which will have 6 pins. This is a standard glassy carbon electrode. The WE1 is used for any test that requires a mercury plate solution. There is then the WE2, which has 3 pins, making them easy to differentiate. Again, it is a standard glassy carbon electrode. There should be no scratches or damage to the black glassy carbon in the center of the electrode. There is a WE3 electrode as well for the last slot. This, as a rule, is only for tests and parameters supplied with the HM3000 upgrade kits and not the base unit that you will have received. The first step to setting up your HM3000 sonde is to take your counter electrode, find your counter electrode slot, find the white arrow on the slip of the counter electrode, match it to the white arrow on the sonde so that the two line up, like so, and push the electrode home. Once that's nice and snugly fit, you can then move on to your reference electrode. Before attaching your reference electrode to the sonde, it should be first checked that the internal chamber within the reference electrode has no air bubbles. As you can see, this particular reference electrode has a rather large air bubble that you should be able to see moving slowly as I rotate the electrode. To refill a reference electrode for a Metalyser unit, simply peel back the sheath from the central chamber, like so, which will expose a hole within the hard plastic outer casing. Take your reference electrode fill solution, unscrew the cap, and you'll find that you have a nozzle with which you can simply tilt up the reference electrode and gently squeeze until you have refilled the electrode entirely. Then simply peel the plastic sheath back down, find the reference electrode slot marked by the R. Again, find the white arrows, align them, and push the electrode firmly into place. Once that's done, you can move on to your working electrode. Your working electrode should be selected dependent on which test you are doing. You will find which electrode will be required within the application note of your test. For now, I shall use your WE1 as an example. Before use, the electrode should be polished. However, we will be covering the polishing of electrodes elsewhere. Since we will be skipping that step for the moment, I'll simply show you. You can find the WE1 slot. You can recognize the difference between a WE1 and WE2 again by the number of pins on your electrode. align the 2 white arrows and push home. Your sonde is now ready for use, bar the polishing of your working electrode, which will be covered later. Once you have polished your WE2 electrode, you are ready to begin your gold plate. To do this, take your polished electrode and attach it into the WE2 slot of your sonde. Once attached, take your AU500 gold plating solution and empty some into your sample analysis beaker. You should fill the beaker to roughly halfway, although the critical point is to fill it enough that the surfaces of all electrodes are submerged, and then attach your sample analysis beaker to your sonde. Once this is done, take your handheld Metalyser unit and select test methods, and then scroll down to your M2-3 conditioning step. Press select. It will only give you the one option, so simply press select again and the plating process will start. It should be noted that the plating process is one of the more delicate operations of the Metalyser unit and can be prone to failure for a number of reasons. Incorrect polishing is one, the other is the co-deposition of mercury, and another is physical damage to the electrode, along with a number of other reasons. To check that this has not occurred, please view the plate verification video, which will cover how to ensure that the plate that you have is correct and suitable for use. Once your Metalyser has finished the process, it will simply display a screen saying scan completed. Simply press select to return to the M2 and 3 conditioning step and use the cancel button on the right hand side of the Metalyser to return to test methods. You will now have a thin gold film deposited onto your WE2 electrode and will be ready to continue onto either a mercury analysis or a arsenic analysis. For a single point standard edition analysis of arsenic using the Metalyser handheld unit, you will require your handheld unit, your AS50 standard, a HM3 buffer, and 70 milliliters of your sample water in a sample analysis beaker. You will also require your electrodes to be properly conditioned and attached to the sonde. To begin, take your HM3 buffer and add it to your sample water. Once this is done, attach your sample analysis beaker to the sonde. Once attached, take your Metalyser unit. You will be presented with the main menu, which contains your test methods, data log, and system options. Select test methods, and then find the AS3 test method. Press select. Scroll down to standard edition. Press select. Will ask you to check that your reference, counter and working electrodes are fitted to the sonde and that the sample analysis beaker is also fitted to the sonde. These are steps that we have already taken, so simply press select. When asked to subtract baseline for arsenic, you will wish to select yes. You will be given an opportunity to set deposition time. You can double or half your deposition time to lower your lower limit of detection or raise your higher limit of detection. It's recommended that you stick with the default deposition time of 60 seconds, as this is what the Metalyser is designed to work at. So simply press select and the Metalyser will begin analysing your sample to produce the first photomegram that it requires. Once your Metalyser has completed its first analysis, it will prompt you to make a standard addition of 20 parts per billion. You can change the concentration of your standard addition by pressing sideways on the trackpad of the Metalyser. If you have historical data, or if you have an expected concentration, then you should match your standard addition to this expected concentration as a matter of best practice. However, if your concentration is entirely unknown, then it is recommended that you use the default 20 parts per billion standard addition. To do this, take your AS50 standard and pipette 280 microliters of your standard into your sample, and then select the appropriate concentration and then press select on your Metalyser to begin the second part of the analysis. Once your Metalyser has finished the second part of its analysis, it will display the concentration of your initial sample in parts per billion along with a temperature reading. Pressing select will prompt a screen asking if you wish to save your results. If you press no, you will be returned to the test methods menu. If you select yes, you will be taken to a screen which will allow you to give the save a file number. Once you've done so, simply press select to save and you will be returned to the test methods menu. This concludes the tutorial on the single point standard addition analysis of arsenic using the Metalyser handheld instrument. For the single point standard addition analysis of arsenic on the Metalyser handheld unit, you will need your AS50 standard, your AS2 arsenic preparation solution, 2.5 grams of AS1 buffer and 70 milliliters of your sample water, alongside the Metalyser unit itself and the conditioned electrodes. The first step in the process is sample preparation. To do this, add your 2.15 grams of AS1 buffer to your sample and then pipette 280 microliters of your AS2 preparation solution into your sample water. Then take your sample analysis beaker and attach it to the sonde, clipping it in place by rotating it. Once your sample analysis beaker is attached to your sonde, take your Metalyser handheld unit and you'll be presented with your main menu. Select Test Methods and scroll down to your Arsenic 3+5, also known as Arsenic Total, test parameter. Pressing select, you will be taken to a submenu where you will need to select Standard Addition. The Metalyser will prompt you to check your reference counter and WE2 electrodes, which have been done in previous steps, and to attach the beaker to the sonde, which we have also done. As such, simply press select and it will take you to the next prompt, which will ask you if you wish to subtract baseline. For arsenic total, press select on yes. It will then prompt you for a deposition time. You can alter your deposition time by pressing sideways on the controls for the Metalyser unit. The reason you would do this is that you can theoretically change your limits of detection, with halving your deposition time to theoretically double your upper limit of detection and doubling your deposition time theoretically half your lower limit of detection. The Metalyser works best with the default deposition time, which covers the ranges quoted in your catalogue. As such, press select and the Metalyser will begin the first analysis to produce the first voltammogram that it requires for a single point standard addition analysis. Once your Metalyser has finished the first voltammogram that it requires, it will prompt you to make a standard addition. The default standard addition is 20 parts per billion. This is if you have no historical data and no expected concentration. If you have either of these, it is best to use a standard addition that closely matches the concentration you are expecting to see. This can be changed on the Metalyser by pressing sideways on the trackpad to alter the parts per billion added. To add 20 parts per billion to a 70 ml sample, take your AS50 standard and your pipette and pipette 280 microliters of your AS50 standard into your sample. Once this is done, go back to your Metalyser unit and press select on the appropriate concentration increase. Once your Metalyser has finished the second voltammogram, it will calculate the concentration of your initial sample as a function of parts per billion and will also display a temperature reading at which the analysis was done. If you press select, the Metalyser will take you to a prompt as to whether you wish to save your results or not. If you select yes, it will take you to a screen where you may give your data a file name. If you press select again, it will save your data and take you back to the submenu for total arsenic. If you select no when asked whether you wish to save your data, you will also be taken back to the submenu for arsenic total. From here, you can use the cancel button on your Metalyser handheld unit to navigate back to the main menu. With the arsenometer unit, the AU gold plating step is a critical part of the process and forms an integral part of your instrument. However, the AU500 plating step, also known as the M2-3 conditioning step, is not something that can be done within the production facilities and must be done in the field. As a result, a number of things can go wrong with a M2 and 3 conditioning step, and errors during this step will severely affect the results of your analyses. To verify that your plate has taken correctly, take a sample of water, preferably deionized water. However, you may use a contaminated sample of water as well, as the analysis we are performing on your plate requires only the difference between several successive peaks after known standard additions. The height of the first peak on its own is largely irrelevant in comparison to the differences between the first peak and the second peak, and the second peak and the third peak, and the third peak and the fourth peak. To determine peak heights, select one of your voltammograms, right click on one side of your voltammogram, select calculate peak and drag the line to the other side of your peak and left click. This will display the peak height in microamps in a box just above the peak, and this is the data you are looking for. For the arsenometer specifically, it should be noted that the peak heights are generally calculated from one area to the next, and then the line for your base should go to a similar area on the next peak. You will notice as your concentration increases, the area to which you should drag this baseline becomes harder to detect. However, the baseline should always be of a similar width. Once you have your 4 voltammograms and their peak heights, you should enter them into an Excel spreadsheet, which will allow you to plot them against concentration added and determine an R² value. Once you have measured the peak heights of every peak on your voltammogram, you should enter the data into a spreadsheet which will allow you to plot a graph comparing the concentration of AS50 standard that you have added to the current observed on every voltammogram's peak. Once you have this data, plot a scatter graph on Excel using the select data function to highlight the concentration added as your X value and your current observed as your Y value. Once you have done this, right click on one of your data points and select Format Trendline. You will find that there is a display R² value on chart. If you tick this, you will then be provided with an R² value on the equation of the line of best fit. If this R² value is above 0.999, then every increase of current is proportional to the increase in concentration, and this is the method by which the arsenometer unit can determine concentrations of samples. If your R² value is below 0.99, then the validity of your analyses are in question, as there is a variation between the increase in concentration and the increase of current observed. If you find that your R² value is beneath 0.99, the likely fault is with your plate, as discussed in the AU500 conditioning solution video. If your plate has any degradation or imbalance, or areas where the plate has not taken as thickly as others, or a seed has attached to the electrode during plating, causing a denser area of gold film, then this will affect the rate of reaction of your electrochemical process, which will affect the observed current that you are getting.